Well, good day to you, students. I don't know when you're watching this, if it's morning or evening, but good morning and good night, I guess. This lesson is going to be about addition and subtraction of real numbers. I'm going to combine it all into one video because they're very similar topics. And that'll be really helpful. So on the addition part, there are a number of things that we're going to talk about. We're just going to talk about adding real numbers. And so just so you know, when we start to talk about the real numbers and we're adding them, essentially that means we're trying to deal with both positive and negative numbers. And so we want to talk about that and give you some strategies for doing that well. And then I want to talk about how to use a calculator, not to get the answer, but to make sure you're correct, to confirm your answer. So we'll talk about that as we go along. So what we're going to start off with is we're going to add numbers with the number line and just really give us a basis for how we can do positives and negatives. Then we're going to introduce two other properties. Remember, we've talked about commutative, associative, and distributive. And those were kind of the how to move and groove and add and multiply things together. The identity and inverse properties are what do you do with zero, or how does zero affect things, and what do you do with opposites? And so we'll talk about that. And then we want to talk about adding without the number line. So in other words, using the number line is how we begin, but then we want to go to without the number line, which is kind of how we have to do it in our head. And this is sort of a way of thinking here. And you want to be able to think this through if doing this kind of arithmetic has been a problem for you in the past. So we'll talk about that. And then we'll talk about the addition rules to simplify algebraic expressions. So we're going to focus more on simplification, collecting like terms. And then there might be a couple applications or two we can go over, but we'll see how long this is. All right, let's get started. Next page. Okay. So what we want to do is add on a number line first. And so we want to start with if A and B are real numbers, okay, either positive or negative, then to find A plus B on a number line, what must we do? So here's how we do it. Here's a number line, okay? And let's pick an example to represent this. So for A, let's call it 3. And then for B, we'll do plus 5. Okay? So for this answer, for this example. So 3 plus 5. So what we do on the number line is we go to 3. That's where we start. All right? And then if we're going to add 5, on a number line, we basically then add 5 full spaces, right? So we're going to add 1, add 2, add 3, add 4, add 5. And where did we end up with? So this was the 5 we added. And so that becomes 4, 5, 6, 7, 8. And so 3 plus 5 is equal to 8. Now, what they give as a rule for this is if you're adding a positive number, okay, so I'm adding 5, adding a positive number. If I add a positive, then I move, let's say if I add a positive B, then I move B units to the right from A. So you always start at the first number, A, and then you move this many units to the right on the number line. And that's how we can use the number line to naturally add numbers. That's why the number line is a great way to visualize numbers. Well, what if you add a negative? So now let's do 3 plus a negative 5. Same sort of thing. If you add a negative, so then 0, 1, 2, 3. And now I'm adding a negative. So instead of moving to the right, that means I'm going to move to the left. All right, and I'm going to go 5. So 1, 2, 3, 4, 5. So 3 plus a negative 5 is going to take me to negative 2. And so in this case, if you add a negative b, then I move b units to the left. Now, when I first learned about positive and negative numbers, and even some of my early experiences with addition, we were doing this on number lines like this. And so I actually find this very natural. I can actually abstract this and think this in my head. Okay? And so remember, if you add two numbers, you start at the first number, no matter what it is. It could be a negative number. You could start there. If you add a positive, you go right. If you add a negative, you go left. And that gives you a good visual for understanding what's happening. Okay? Now, that then takes us to the next situation, which will be some number line properties of addition. So some more properties of addition. Okay? And those properties are what are called the additive inverse property, and the additive identity property. And so, essentially, the additive identity deals with a property of 0, okay? And the additive inverse deals with opposites, okay? And so let's look at opposites on the number line, all right? If I have 0, and then I have some positive number a greater than 0, okay? So I'm already here. This is where I start, and I want to look at a plus the opposite of a. Now, if I go to what I just did, I'm now adding a negative number. Now notice negative a is negative because I said a is positive. Saying a is greater than 0 means it's positive, okay? So a is positive in this case, not because the sign is positive, but because I said a was positive. Otherwise, a could be positive or negative. All right, if I don't say, it could be either one. If I say, then it's only one of them. And then negative a is the opposite of a. So if I have a, and then I move negative a, whatever that is, dot, 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 I'm going to end right back up at 0, okay? So a plus the opposite of a is 0. Well, what if I started with a as a negative number? So now I'm out here and a is a negative number. So a is less than 0. So what would a plus the opposite of a be? Well, if a is a negative, then the opposite of a is positive. So then we're going to move in a positive direction, A units, and therefore that takes us to 0. So in this case, the opposite was a positive if the number was a negative. Okay? This also shows you that saying what a number is what tells you whether it's positive or negative, not if the sign is there, especially when you have a variable. So I wanted to do it that way. But in either case, notice A plus the opposite of A. Whether I started with a positive and then had a negative, or I started with a negative and then had a positive, will take you back to 0. So they're both equal to 0. All right? That is the additive inverse property. You would say A plus the opposite of A is equal to 0. Okay? What's the additive identity property? Well, the additive identity preserves the identity of a number. So what we're looking at is something like this. What if A, any number now, positive or negative, and I add 0 to it? What's that going to be? Well, let's look at the number line. So here's a number A right here. And if I add 0, I either move to the right 0 units or I move to the left 0 units, because 0 is neither positive or negative, so I could do either one. But if I go 0 units right or left, I'm still at A. That's it. I'm still there. And so the identity is preserved if I add 0. That's why it's called the additive identity property. Okay? So a number and its opposite, they are called additive inverses. The identity is the number 0 for addition. Okay? Now, once you have that, you can then use that as you do problems. Okay? So, they then talk about adding without a number line, and this is where you get the rules. Okay? And if you remember the rules, all right, the rules of adding without a number line were this. If you add two positives, so if you add 15 plus 6, then you just add normally and you get a positive. If you add two negatives, you add them normally. 15 plus 6 is 21, but the answer will be negative. Now, why does this make sense in each case? Go to the number line. If you start at 15, then you're going to add 6 to that, and you're going to end up at 21, right? If you start at negative 15, you're going to go to the left because you're adding a negative 6. So you're just going to stay in the negatives, right? And so this makes sense on the number line, all right? And so even when I do problems like this, I sort of have a mental picture of this. And this really helps me to get these kinds of problems right when they're both positive or both negative. And I don't have to make a rule for positives or negatives. If I can think this way, then it becomes very obvious to me. I started a positive and I'm adding a positive, so I'm still going to be in the positives, right? I lost $15 and now I'm losing $6. So I'm going to lose a total of money that's higher than either one individually, right? So that makes sense in my brain. Now, what happens when you have a positive and a negative? The rule states turn it into a subtraction problem. In other words, you take the absolute value of the two numbers. The absolute value of negative 13 is 13, and the absolute value of 4 is 4. And so what you do is you do a subtraction problem, 13 minus 4. But then the rule states you take the sign of the bigger number. So the answer will be negative. That's how the rule is stated. Find the difference between the absolute values, larger absolute value minus smaller one, and then take the sign of the number that has the larger absolute value. So that's what I've done here. This is like the in-between step. So the answer is negative 9. Okay? Now, let's show you why this works on a number line. If you look at this, you go to negative 13, but then you're adding 4. Now, that's not enough to get you all the way to 0, right? It's only enough to get you up to negative 9. And so I can see why if whichever number has the bigger absolute value, that's the sign I choose. Okay? And in fact, you can do this mentally quite easily if you practice it and remember it. So, same way we do this one. Okay, we look at this problem, and the absolute value of 27 is 27. The absolute value of negative 20 is 20. So I do this subtraction problem. And the sign I take is of the one with the larger absolute value. So my answer will be positive 7. And you can imagine how that works on a number line. All right? And so we get the rule, if you add a positive or a negative, the answer takes the sign of the one with the larger absolute value, and then you just subtract the numbers. Okay? And so, or subtract the absolute values. And that's the rule. And whenever I'm doing integer arithmetic, I do this in my head. Now, before we go on, I want to talk about calculator usage. You guys all have a calculator. If you type into the calculator negative 13 plus 4, so you can write the answer negative 9, then you are not helping yourself to really learn how to do this. However, if you try to think of the rule, negative 13 plus 4 is equal to 13 minus 4, difference of the absolute values, take the sign of the larger one, is equal to negative 9. And then you type this in your calculator to check and see if you're right, then that's a great approach, okay? And in fact, every problem you should try and get the answer on your own and then check it with a calculator. If you're the kind of person that makes lots of mistakes with arithmetic, you can always check with a calculator. And I would do that because that will help you correct errors. And you may look at it, let's say you did a common error, you put 9 here. Well, I forgot to take the sign of the number with the larger absolute value. I just wrote 13 minus 4 and got 9, but I forgot to realize that the answer was negative. Because negative 13 has a bigger magnitude than positive 4. And so it'll help you to find errors, and then you can work on your thinking. And so that's how I would use your calculator in this case. So my comment is, you should get all these problems right. Okay? However, make sure you think through how to do them on your own. Okay? And then if you make mistakes, show your correction. Show a correction. I always like to say, do your correction and then highlight it. You know, highlight that correction. So if you do a correction, you can come in and highlight it, or you can do it in a different color. All right, anything like that. Well, when I look at your paper, I'll say, oh, Johnny has done this problem, but he put a correction here, and then that'll help me look at it, and that may be something we talk about the next class. I might be going, oh, okay, what kind of correction did he make? Oh, this might be something I want to emphasize. So it helps me to help you as well. So always on your paper, show your correction. Don't erase your mistake. Put your correction down and talk about why you fixed it, okay? And that's why all your problems should be all correct, all right? That's how you would do it. Do the work, check with a calculator. If there's an error, put your correction on the paper. You will find that this makes you a better mathematician, and it'll help you not forget things, okay? Now, final comment about this is this rule applies in any positive and negative situation. If you have 4.6 plus a negative 5.1, all right, I know since the negative has the greater absolute value that my answer will be negative, and then I just do 5.1 minus 4.6, right? And so I get negative 0.5. And now I'll type this into my calculator, see if this is correct. If it is, then I feel comfortable, I understand it, and I can go on. The point here is this rule works with decimals. This rule also works with fractions, okay? If you have 2/7 plus a negative 2/5, let's say. So these need a common denominator. So that means I want to write equivalent fractions. 7 and 5 are both prime. So the common denominator is 35. So I multiplied this one by 7/7. And this one by 5/5 to get equivalent fractions. So now what I end up with is I get 10/35 plus negative 14/35. So the one with the bigger absolute value is the negative 14/35. So my answer is going to be negative, and then I take the one with the bigger absolute value and subtract the one with the smaller. So the algorithm works no matter whether you have fractions or decimals, whether the numbers look different than whole numbers. And this will be a negative 4/35. Okay? Next thing. Finally, the last thing is you have to start to apply this. So you get something like 7 times y minus 3 plus negative 9y plus 15. Okay? And so when I look at this problem, first thing I notice is there's a distributive property here. And so we need to multiply before we add things. So I do my distributive. So they're starting to mix things up. And this is simplifying. Simplify means do all the arithmetic, which means collect like terms. All right? So I now get 7y minus 21 plus negative 9y plus 15. Now, I have some like terms here. Mentally, I can use commutative and associative to move things around, all right? And I can think of the negative 21 as plus a negative 21. So now I can move that negative 21 around if you wish, because now they're all additions. So I have commutative, so I can change the order, and then I have associative, so I can group together the things I want. In any case, this would be rewritten as 7y plus a negative 9y plus 15 plus a negative 21. All right? And now I do the addition. So now I'm collecting the like terms, and the addition here is 7 plus a negative 9, okay? Which means it's going to be the opposite, because negative 9 is a bigger absolute value of 9 minus 7 times y. And same thing here, it's going to be the opposite of 21 minus 15 when I add those together. So I'm adding the opposite at 21 minus 15. So now I can finish this problem. So 9 minus 7 is 2, so I get a negative 2y. 21 minus 15 is 6, so it's a negative 6, so I have plus a negative 6. And I can rewrite this as negative 2y minus 6. Okay, subtracting 6 is the same as adding a negative 6. And we'll talk about that here in just a moment. But this would be considered simplest form. This would be 2, but this one's probably better. Okay? All right, and that's sort of the last part that you have to do. So let's go to the next lesson. Okay, so when we do subtraction, we want to use the definition. And the definition of subtraction is this right here. If you have two real numbers, a and b, such that you have a minus b, then that's equal to a plus the opposite of b. We call this the add the opposite definition of subtraction. And so how do I do this in practice? So I do like 7 minus 10. I can rewrite that as 7. So I'm going to add the opposite of 10. Okay? So I change the subtraction to addition. And then I look at the number, which is just 10. And so I put the opposite of 10. What this has the effect of doing is it turns our subtraction problem into an addition problem. So now we just follow the addition rule. Oh, the number with the largest absolute value is the negative, so my answer is negative. And I take the larger absolute value minus the smaller absolute value. And so I get my answer, negative 3. Okay? Now, I do so much of this, I do these in my head now, but the key is turning it into addition of the opposite. And once you do that, that makes the problem into an addition problem, and you can use the number line to model it. And it makes perfect sense. You could also think, oh, here I am at 7, now I go negative 10, right? And you keep going until you end up at negative 3. And so this is a perfect way to do it. So what if you got those pesky double negatives? So you have like negative 9 minus a negative 6, like that. So how do you deal with that? Well, change it. It's subtraction problem. So take the first number, change the subtraction to addition, and then take the opposite of the negative 6. So this becomes negative 9 plus 6, which is the opposite of 9 minus 6. That's our work when we're doing these. We take the absolute value of each and subtract the smaller from the larger. So we get -3 there as well. Okay? So this works with fractions or decimals. It's a fairly clean process. So a -3/7 minus 2/3. Okay. And so I want to add the opposite. So -3/7 plus a -2/3. So notice we change the subtraction to addition, and then the number becomes the opposite. So now I have -3/7 plus 2/3. So I look at the denominators. 7 times 3 is a common denominator, 21. So I need to multiply 3 over 3 times -3/7 plus 7 over 7 times -2/3 to get the common denominator. And that's -9/21 plus a -14/21. So now I'm adding a negative and adding another negative. So on the number line, here's 0. I start at -9/21 and then I add -14/21 to it. So all I really need to do is -9 plus a -14 here in the numerator, and then put it all over 21. So that'll be a -23 over 21, and I'm done. Okay? That's your process. All right? Now, if you have a bunch of additions and subtractions in a row, if you have a bunch of additions and subtractions in a row, then there is a fairly systematic way that you can deal with that. All right? So suppose you have a problem like this, and you have a lot of subtractions in it. Well, I think the easiest way to take care of it is to change all the subtractions to add the opposite. So I'm going to put the 10 here. This subtraction becomes addition. This -12 becomes add the opposite. This subtraction becomes addition, and I add the opposite. This subtraction becomes addition, and I take the opposite, so I add 6. And this subtraction becomes addition, and I take the opposite, -19. So now the whole problem's an addition problem. So I can use commutatives to get the positives and negatives next to each other, which I would do 10 plus 12 plus 6 plus -4 plus -19. All right? And so this gives 22, 28. And then I can add the two negatives together plus a -23. And so I can see mentally, I can see that on the number line. That's just 5. Okay? 28 plus -23. Another good model that works for this is suppose you had like black poker chips, right? And you had 28 of them here, all right? And then over here, you had 23 red poker chips. All right? Then what you can do, and there's more in each of these, so 23 and 28. Then what you do is you want to add those together. A black plus a red, they undo each other. sort, and a black chip, if I put 28 of them here, that's like I have 1 28 times, right? 1 times 28 is 28. So by putting a black here, I'm saying it's 120, it's just 1/28 of the 28, which is 1. Same thing with the reds and the 23. So it's like, except the reds are going to be a -1 because this is a -23. And so basically B and R, 1 plus -1 is, by additive inverse, 0. And so what I do is I do that 23 times with the blacks and the reds. And at the end of that, I'll have 5 black ones left over. So that's a nice way that you can think about it as well. All right. And so to wrap this video of these 2 sections up, what I tend to do at this point is when I get to an algebraic expression, I do just what I did on the last problem with the numbers. I change all the subtractions to addition. So this subtraction becomes 15 plus the opposite of -3x, which is 3x, plus 8x. And then this subtraction becomes add the opposite of -10, which is 10. So now I can collect like terms. So 3x plus 8x plus 15 plus 10. And that then becomes 11x plus 25. And I'm done. Okay? So that's essentially your lessons in your textbooks, 1.5 and 1.6. I'll give you the homework tomorrow, and you'll be able then you'll be able, after watching these videos, to ask any questions and get any helps that you may need. Alrighty? Okay. Talk to you later. Bye.